Alright, let's look at the homework 4.7, problem number 9. Alright, so we want to find the angle so that the gutter has the maximum capacity. Right? So in order to maximize the capacity of the gutter, we just need to maximize the cross-sectional area. So we're going to look at the this trapezoidal region, and we want to maximize this area. Right? So in order to find the area of this trapezoid, so area A is going to be equal to, right, so we have to know it's a 1/2, so 1/2, and the bottom base is 10, right, plus top base is going to be, so if you go straight up here and go straight up there, then we know that the length here would be, of course, 10. It's going straight up. Right, then using the trig ratio, so this is 10 times cosine, so this is going to be just 10 cosine of theta, and of course the same thing, it's symmetric, 10 cosine of theta, and the height is going to be 10 sine of theta, so this is going to be 10 sine of theta. Right, so we know that let's see, so top will be 10 plus 20 cosine theta, so 10 plus 20 cosine of theta, right, and times height would be 10 sine of theta. Right, so if you simplify that, you can see, so this is going to be just 20 here. Then we can just distribute this 1/2 to each one. We will get right, 10 plus 10 cosine of theta times 10 sine of theta. Alright, so we get the alright, so pull out let's say 10 from here, 10 from there, so it's going to be 100, and then you have a 1 plus cosine of theta sine of theta. Right, so we want to maximize this area, so we're going to take the derivative. So I'm going to take the derivative of this area function with respect to theta. We will get so 100 is just a constant, put it there. Alright, then we can take the derivative using the product rule. So this is the first guy, this is the second guy. So derivative of this guy is derivative 1 is 0, derivative cosine is negative sine times sine of theta, so it's negative sine squared of theta, and then plus, right, you have 1 plus cosine of theta times the derivative of sine, so that would be cosine. Alright, then since this is going to be cosine here, so I'm going to rewrite this guy as alright, so negative sine squared can be written as let's see, cosine squared minus 1. Right, and then you would have plus, you have cosine of theta plus cosine squared of theta. Alright, so we have we can clean up 100, then you have 2 cosine squared, those are combined, so 2 cosine squared of theta, and then you plus here's a cosine, so you have a cosine of theta, and then we have negative 1, so minus 1. Alright, then we can factor this out. So we can factor it out as 2 cosine of theta and you have a cosine of theta, and then you would have plus 1 here and a minus 1 here, right? So if you set that equal to 0 to find a critical number, you would get this, right? We want the cosine of theta to be 1/2, and or cosine of theta to be -1, right? And a cosine of theta equals 1/2, so that would be theta equals 1 pi over 6. And in order to cosine of theta to be negative, so theta is going to be pi. But you can see that we want theta to be between 0 and pi over 2, because if you pass pi over 2, there's no way the cross-sectional is going to be larger. So between pi and the pi over 2, the only critical number would be this guy, right? So that means that when angle is pi over 6, the cross-sectional is the largest. So you can go here, all right, then type in pi over 6, right? Pi over 6. Oh, okay, pi over 6 is 30 degrees. Sorry. When pi over 6, oh, actually, I made a mistake. It's pi over 3. That's what I meant. Did I say pi over 6? Yeah, I did. Right, I meant cosine of theta is 1/2 when angle is 60, so that will be pi over 3. Alright, so let's go back and pi over 3. So let's check the answer. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.